Welcome to Sundar's lecture. This is lecture number 18, and in this lecture we are going to see how to implement a full adder using two half adder with one OR gate, right? So and we are going to see half subtractor and full subtractor and how to build a full subtractor using two half subtractors, right? Now, what are all the topics we have seen in the previous class? See, we have started with the combinational logic circuits, right? And we have seen what is combinational logic circuit and an example problem, and then we have gone to adders, and we have seen what is half adder and full adder, right? So we have drawn the diagram for full adder. Now this is my output equation, right? So what I will do now, I will take these two things to here. This is the output of sum and then carry, right? Now what I need to do, I have to draw the diagram with two half adder diagram. I have to build one full adder. That is my ultimate aim. See, I don't have any problem with this one because I can easily build this. Anyhow, I just tell you after deriving the expression for carry. So what I'm going to do, I'm going to derive an expression for carry. See here, the carry, in carry you keep AB as it is. Why I need to keep AB as it is? If you go to half adder, you can see this one. Already you have AB, right? So what I'm going to do now, let me do this. AB, you keep AB as it is, plus what is the missing term here? It is B, right? So put B plus B bar. B plus B bar. In this term, I'm missing term B plus. What is B plus B bar? It is a tautology, right? So it will be 1. So now what you do here, BC into A plus A bar. This is also tautology, right? So it will be 1. So I can derive this expression as AB plus ABC. I'm just writing down plus AB bar C, and then plus again this is ABC plus A bar BC. Now what is this one? This ABC plus ABC. I have already told you, right? A plus A will be what? The same term, right? So I can leave this one. So what you do in these two terms, you take AB outside commonly. So what you will get 1 plus, if you take AB, so it will be C. So that's all, right? So then what is the common term in these two? This one and this one. C is the common term, right? So take C commonly outside. What you will get? It is AB bar plus A bar B, right? So now this term goes to 1. Why? Because this is a 1 plus anything will give you what? 1, right? So next what you do, you can write this AB separately plus this one. What is this one? What is this? AB bar plus A bar B. It is like XR, right? So it is an XR. So C into A XR of B. So now you take this as the final expression for carry. So what it will be now? See here, I will take a carry. I will take the half adders first. So this is one half adder, right? So this is one half adder, right? So I will give AB as an input, and as well as I have an AND gate, right? This is my AND gate, and I will have two inputs here. One can be given straight away here, and another one can be also given here, right? So now what will be the input here? This is A, and then this is B, and what should be the output here? It will be A XOR of B, and what is the output here? It is AB. That's all, right? This is one half adder. Now what I will do, I will draw the another half adder, right? This one. Here you put another AND gate. Maybe I will just put here, this and gate, right? So now what I need to do, maybe I will take this as now sum. That means sum is what? A XOR of B XOR of C, right? So A XOR of B XOR of C. Now what I need to do? I can connect this one, right? This one here, right? So you just connect this input here like this, and you are getting A XOR of B. So if I give C here, then what happens? Then what happens? So let me do this one. Take C, obviously. Give here as an input, right? Give here as an input. Then what happens here? You will get A XOR of B XOR. Already you are getting A XOR of B and C. So it is 3 XORs, right? So you got sum now. No problem with sum now. And for carry, you should have an OR gate, right? So why I am doing this one? Because you have plus here. So obviously you should have an OR gate. So what you do now, you draw the OR gate here. Draw the OR gate, right? Draw the OR gate. And the OR gate expression should be what? Carry should be is equal to what? AB plus, and the another input should be C into A XOR of B. We know this one, right? So AB one input I can get it from here, right? Simply one input of AB I'm getting from here. So you just write it down. You just write it down. This is AB. This is AB, right? No problem with AB. And this AND gate, you just draw this one, just move this. Now you see, I've just moved this. See, this output of AND gate should be what? C into A XOR of B, right? So C into A XOR of B. If it is so, what I can do now? What I can do now? I can easily connect this one, right? So get it from here, get it from here, just here, and then you can connect here, right? So now what happens now? If I get this output, I can write this one. So for this I need C as one input, right? No problem. Maybe I will use a different color so that it will be easy. C from one input. I have given this one, and what is the other input? A XOR of B. You can get it from here, right? Simply, right? Now this is the diagram. Now this is the diagram. See here, we have just constructed the full adder output. That means this is the sum output and this is the carry output. Using what? This is one half adder and this is the another half adder, right? So I will just put the boxes here, and you can see here. This is half adder 1 and this is the second half adder, right? So half adder 2. Right, so this is one of order, this is one with one OR gate. That is what they given you, right? So now we have constructed, right? So this is the procedure to do this one. So what we will do now, we will go to the half subtractor now, right? Now this is the half subtractor, and we will generally call it as 2-bit subtractor, right? Whatever we have done for adder, it is same for the subtractor too. Let me take this as now AB input, right? First we will draw the truth table. And then we will go for the out. Here, what we will do, D, which is nothing but this is difference here. So anyhow, I will write it for the first time. This is difference, and this is now borrow, right? So now this is the truth table. So what we will do generally, truth table will be 0 0 0 1 1 0 1 1. All right, we know this one, right? So this is the truth table. So what we will do now, we try to write the output expressions, like how will you do this one? So this is difference, this is borrow, right? So generally we will call it as D and generally we will call it as B here. So if you subtract 0 from 0, what you will have? So this difference will be 0, borrow will be also 0, right? Can you subtract 1 from 0? No, right? It is not at all possible, right? So what you generally do, you will get and borrow here. So if you get borrow, it becomes 1 now. So since you get borrow, you put 1 here. So what is the answer if you subtract 1 from 10? See here, it is not 9, it is an binary subtraction. So obviously you will get 1. 0, 1, and then what is the next value? It is 10, right? So 10 minus 1 will give you 1 here, right? So try to understand. If you subtract 1 from 0, the difference will be 1 and you are not getting any borrow, so it becomes now 0. And if you subtract 1 from 1, what you will get? The answer difference itself is 0 and you are not getting any borrow, so it is also 0. Can you understand? So this is how you need to draw the diagram, right? So what is this one? I have already told you. See, I am not going to put any corner of map for this one. Why? Because we can directly write the answers, right? So what is the answer for difference? So tell me what is difference. So it is 0, 1, 1, 0. See here, if the inputs are inverted, the output becomes 1. So what is this one? Straight away it will be what? A XOR of B. That we know straight away. And you see this one. Is this related to any gates? No, it is not related to any gates. Try to understand. There is only one is there. If there is only one, straight away you go and see what is this one. What is this one? So I will just write it down. The borrow. This is borrow. We generally call it as borrow. See, you don't have any ones here. Only you have one here. So what you do? You straight away go here. What is this value? This is A, right? In A, you are giving input as A 0 and in B you are giving input as 1. So what should be the output here? If you have single 1 in the output, then it will be like it is A bar and then B simply in SOP functions. If it is a PYS, then it will be what? Then it will be what? A plus B bar. Anyhow, I'm not going very deep into that. So this is the output equation. So what should be the diagram now? So I will again I will go fast now because we have seen everything in the previous one, right? In a header, whatever you have done, the same thing is existing here too. That is why I'm just going very fast. So this one, and then I should have an AND gate here. So I will draw it down anyhow. So this one. So what you can do now, maybe see this is now A, this is now A, and this is now B. And I am taking this one to be difference, and that should be is equal to A XOR of B. Simply, I have got the answer. And now what is this one now? A bar into B, right? So what I need to do here, I have to take this A and I have to put a NOT gate here so that it becomes now A bar. Simply, right? So now I got A bar, and what is the next one? I need to give this one to here. This is now B. So what will be the output equation now? So this becomes now A bar and this becomes now B, right? So simply, so the borrow should be is equal to A bar B. That's all. Now this is the diagram for the half adder. Okay. So now what we will do? We will go for the full adder now, right? So next topic it will be full adder. All right. Right now you see here, so this is full subtractor and a 3-bit subtractor. So I have told you, right, it is an adder. No, it is not an adder, it is a subtractor, right? So what you do now, you have to, this is difference and this is now borrow. What you do, you subtract 0 from this 0. What is 0? 0 minus 0, it will be 0, right? Again 0 minus 0, it will be 0. So what is the answer for difference? For difference also 0, you are not getting any borrow, so it is 0. And obviously you see here 0 minus 0, it will be 0. Now, can you subtract 0 from 1? No, right? You cannot do that. So what you need to do, you have to get a borrow here. So since you are getting a borrow, you put 1 here. So this is now 10. 10 minus 1, the value will be 1 simply, right? So this is 1. And directly you cannot subtract 0 from 1. So obviously you have to get borrow. So put 1 here. So you are getting borrow means it becomes 10. So 10 minus 1, what is the value? 10 minus 1, it will be what? 1. Can you understand? 10 minus 1, it will be 1, and 1 minus 0, again it will be 1. So this value will be 1 here. And you cannot, obviously you cannot you cannot subtract 0 from 1, so you have to get borrow here. So it will be now 10. 10 minus 1, it is 1. 1 minus 1, it becomes 0 simply, right? Can you understand? Next one, 1 minus 0, it is 1, and then 1 minus 0, again it is 1. So difference is 1. I am not getting any borrow, so it becomes 0. So 1 minus 0, what is the value? It will be 1. 1 minus 1, again it becomes what? 0. So this is now 0. This is now 0 and I am not getting any borrow. So this is also 0. So 1 minus 1, it is 0. 0 minus 0, it is 0. So this value will be also 0. I am not getting any borrow, so it is now 0. Now you see here, 1 minus 1, it becomes now 0. 0 cannot be subtracted from 1. So that what I have to do, I have to, so here it is already 0. And I have to get a borrow here. So I have to put 1 here. So I am getting borrow here. And 10 minus 1, it is again 1. So now this is the diagram for, this is the truth table for the difference, and then this is for the borrow, right? So what is this one now? And I will put the K map here. I will put the K map here. Say I've just drawn the K maps now. So you put the difference in this one, in this K map. So this is 0. For 1 it is 1, for 2 it is 1, for 3 it is 0, right? So for 3 it is 0, and then for 4 it is 1, and then for 5 and then 6 it is 0, and for this one it is 1. See, I have already told you. Now you check it out. This is 2 are inverted, this is 2 are inverted, inverted, inverted. So what I have already told you, and if you compare these two adjacent cells, everything is inverted now. So I have already told you. Simply, if you see anything like this, for all adjacent cells, if it is inverted things, then you can directly write difference should be is equal to A XOR of B XOR of C. Simply, you don't need to do anything. I've already told you, right? So this is the final equation. I'm not going to derive this one. Anyhow, if you derive this one, you will get this one finally. I have done it for adder also. So you just verify my previous lectures, right? So what is this one now? You just write it down for this one. This is 0, and for 1, 2, 3 it is 1. So 1, 2, 3 it is 1, and then again for 7 only it is 1. So this is 0, this is 0, and this is also 0. So what you do now, you can map this one finally, right? So there is no octet quad possibility, so I have to go for now pair. So these two are one pair, and these two are one pair, and mm, these two are one pair, right? So you can write the expression now. Maybe I will write it down here. Maybe I will write it down here. Borrow. B can be written as what? So first one, this one is A bar, and then what is the common term in these two? C is the common term. Put plus, and then for this one you can write it as A bar, and what is the common term in these two? It is B, right? So B, put plus, and then what is this one? It is straight away it will be now BC. So you can simply see this one now. This is the final expression for the borrow now. So what you can do now, you can draw the diagram for this one. I will take it to the next page. Right, now you see for this one, there are three inputs, right? So what you can do now for XR, you can draw the XR, right? You can draw the XR like this, right? This one, and this one, this one, this one. What it will be now? If this is A, this is B, and then this is C. So obviously the difference now become A XOR of B XOR of C, right? This is the whole idea. And for this one you need to draw the OR gate, right? So if you draw the OR gate, so I will draw it down. So this is now OR gate. Now this will be the value of carry. So this is not an OR gate anyhow. So this will be now the value of carry. Sorry, not carry, it is borrow. So borrow should be what? It is A bar B plus A bar C plus BC, right? So what you can do now, you can just take down from here. Okay, you need to draw three AND gates, right? So three AND gates has to be drawn, right? So if you draw like this, and you can draw another AND gate like this, right? So now this is one input, and you can go like this for the second input, and for the third input you can go like this. And what is this one now? This one, it is A bar B, this should be A bar C, and this should be BC. Right now, these are all should be the inputs, right? So from here on, what you can do now, you can just take it out from here, and then right from here, you just draw this one as a NOT gate, right? So right, this one now becomes A bar, and the same A bar has to be given here, right? So this same A bar, sorry, this A bar has to be given here. This is also I have to do, right? So now I need to give here B, right? So how can you give B now? Take it from here and just put it down here. This is no B, right? And you have to see, you have to give C here, right? So this one, right? So from here you just connect this one. So this is now C, and from B and then C you have to give here. From B you take from B, give it to here, and you have to give C. So from here you can give here, right? So this is the input now. So now this is the diagram of, a full subtractor, right? Now what is the other thing? The next topic, you would have predicted it. What is that? You have to implement a full subtractor using only two half subtractors with one OR gate, whatever we have done in our previous thing in adder, right? So you have to implement the same thing in the subtractor too. So I will just do this one. So I will take it to the next page, right? Now full subtractor using two half subtractor with an OR gate, right? So now difference is no problem. I have already told you, like adder, but the carry you have to rearrange this equation. So what we can do now, from this, what you do, you just write this A bar B. You don't do with anything with A bar B because we already have A bar B, right? You can see the half adder now. In half adder, this A bar B is already there, so you don't do anything with that. And for this one now, A bar C, put B plus B bar, put B plus B bar here. And for this one BC, you put A plus A bar, right? Simply. And now what you do, you take this A bar B as it is now, and this will be now A bar BC, and then put plus A bar B bar C, and then here also it will be A B C plus this will be A bar B C. And you can see this one now, these two are the same term, this one and this one. So what you can do now, you can neglect this one, and you can now write what is this one common term in these two. It is A bar B. You take commonly outside, it will be 1 plus C, and you can see here what is the common term in these two. It is C, right? It is C, right? So put plus, take C commonly outside now. If you take C commonly outside, what you will have now? It is AB plus A bar B bar, right? Now you will have an expression like this. And what you can do now, you can just write this is A bar B, right? Because this one goes to 1, and this one plus C, what you can write now, this will be now, see here, what is this one now? Actually this is AB plus A bar B. What is this one? This is A X NOR of B. Am I right or wrong? Am I right or wrong? So what you can do now, this one I can write like, this is A bar B, this is A bar B plus C into A XOR of B, the whole bar. You have seen this one, right? This is XNOR, and the inversion of XNOR can be written like this. Now what you do? You just draw the diagram for two half adders. So I will just draw the diagram. What we will do now? What we will do? We will draw like this. This is an XOR gate. This is an XOR gate, and you have two inputs here. Simply, right? This is two inputs, and you will have an OR gate like this, right? So AND gate, sorry, not OR gate. This is AND gate, and you will have like this now. And you know that this one, this will be connected to one NOT gate, and this can be straight away connected. So now you see what is the output here. It is A XOR of B, we know, and then this is now A bar B. This is also we know. Right now this input is A and this input is B. We know this one already. Now what you do, you just draw another one, this XOR, right? You can draw like this, and you put an AND gate here, right? You put an AND gate here. So what you do now, you just connect this one right here, right here. This is one input I have already given. And what you do now, you just take a C here, This is now C. So what happens now? A bar B, A XOR of B is given, C is given. So this one I can write it as difference now. Take a different color, difference, and what is this one now? One input is A XOR of B and the another input is C. So this one now becomes now difference. And for this one you have to put an OR gate here, right? So I have already told you, right? Like you put an OR gate here, this OR gate, right? Now this is the output now. So I can generally write it as not carry. This is borrow. Sorry, this is borrow, right? Borrow. I have made a mistake here. So now this is now borrow, and what is the output here? It is A bar B plus C into A XOR of B, that is inversion of XOR of B. So what you can do now, this one input, so this now this should have one input as this one. I can connect like this one here. So I have got one input as A XOR of A bar B, and this should be given from here. What is this one now? This is A XOR of C into A XOR of B whole bar. Now what you can do, simply you have C here, so you can straight away put C, no problem. C has been given, and this one you can take it from here, put a NOT gate, right? So you will get it down this one, right? So what you do, you just get it from here, get it from here, you just draw a NOT gate and you put here. So what is this one now? Simply this is C, and what is this one? What is this one? This is like A XOR of B the whole bar. So you are getting this one, right? So this is now can be connected to this one, OR gate. Now you see this one, A bar B has been given from here. The C XOR of C into A XOR of B the whole bar has been given here. Now you see which one? Which one? So you can just see here this one. This one is one half adder, right? And then you can see here this one. This one is another half adder, right? Can you understand? Can you understand? This is half adder. So this is half adder 1 and this is half adder 2 and this is another OR gate, right? So this is an OR gate. So we have just implemented, right? No. So this is the final answer. And now in this class, what are all the topics we have seen in this class? So what we have seen, we have started with the full adder using two half adders and with an OR gate, and we have derived the expression, we have implemented this one, right? So this is one half adder, this is another half adder, we have combined with an OR gate and we have built a full adder by using two half adders. And we have gone for half subtractor, we have drawn the logic diagram and we have derived the expression. And also we have gone for we have seen full subtractor, and in full subtractor we have seen what is the difference and what is borrow and the equation for difference and borrow, and we have taken this logic diagram, right, from the derived expression. And we have also gone for full subtractor using two half subtractor with one OR gate, right? So we have derived the expression for borrow separately. We have to draw that, we have to derive that one, and then we have finally drawn full subtractor using two half subtractors, right? This is not an adder, this is subtractor, again this is subtractor, this is subtractor, right? So we will see in the next class.